All right, now this is part 2 of combining transformations. We've got to the point where we realize that the order that you do the transformations in only matters when you have a translation combined with one of the others, with reflection, expansion, or compression in the same direction. Now, this is going to be a series of functions here. We're going to track a single point here. We're going to say, what if this point, we're on this function? Where does that point get transformed to? So this we have this is a vertical compression times a quarter, and this is a horizontal compression times 1/3. So we're going to look at our point here, and we're going to track this point. If we do, now each of those affects a different one, so it doesn't matter which one we do first. We'll do the vertical compression first by a quarter. That's going to mean that 24 turns into a 6. Horizontal compression times 1/3. Okay, imagine that 12 is going to turn into a 4. Right? So that's that new point. Even whichever order you did it in. We'll track this same point here. Let's 24. And watch where it goes. This is two things. It is a horizontal reflection about the y-axis, and this is a horizontal compression times 1/3, like in the previous one. Now, even though these are in the same direction, we can do it in either order here first. It's not going to change the y value. There's no change to that. It's going to change this x value. That 12, if you do the reflection first, is going to become -12, and then the -12 is going to become -4. But I think you can see that if you did it in the other order, it wouldn't matter, right? If you made it 4 and then -4, wouldn't make a difference. So that's where that point goes to. These next two here, we'll get them both on the screen at once. This 20, missed my one, 12, 24. This is a vertical reflection and a vertical compression by a quarter. Okay, now that's going to change the y value here, not the x value. So that's going to stay the same. That is going to make it, it's going to take the 24, whichever order, even if you do the compression first, it's going to become 6. That's going to be reflected to -6. Now you're starting to having to think about order here, because we have a translation. That is a horizontal translation of 5 to the left. And this represents two things here. This represents a horizontal compression times 1/3, and this represents our horizontal reflection. So we're combining 3 horizontal things. Now these two, the order doesn't matter, but all we know is they have to, since this is this factored form in here, right, with that second set of brackets, that's that factored form. It means this has to come last, right? That's happened last, which we saw before. So if we do that to our point here, okay, so first we'll stick with 12, 24, and our horizontal reflection and a horizontal compression are going to get us to -4. So we'll do these two things first, and then we'll go 5 to the left, which is going to get us to -9. Okay, 5 to the left, imagine where 4 is. Okay, where -4 is, moving 5 to the left, it's going to get you to -9 there. Alright, so as long as you do that translation afterwards, you're good. That next one, now notice that this one, on the other hand, we'll leave that other one on the screen, right? This one was in that factored form. This one is not, right? This is not that extra set of brackets in there. You could do it sort of out of order and do the translation first inside there before this stuff, and you'll see that you get the same thing. But first of all, we'll do it, which is probably the safer thing, which is anytime you see you have an equation that's written in that non-factored form, change it to what we're sort of calling standard form here. That what's in blue there, if I factor that -3 out, it's that. Okay. So what I have in blue up above there is the same as what's in blue here. That factor, you factor out the -3, and it's written in that form. Then we have tons of transformations here to do. We have our vertical reflection. We have a vertical expansion by 2. We have a horizontal reflection. We have a horizontal compression times 1/3. we have this kind of has everything involved here. Let's move this up a bit. And let's move this down a bit. Make lots of room for this, all these transformations. We have, to finish the list there, we have a horizontal translation of 2 to the left, and we have a vertical translation of 7 up. Now, if we do all those changes on the points all at once, it's getting lots of blue here. I'm going to change that so we can not necessarily lose track of it. Okay, we'll start with our 1224 over here. Now, I'm going to do everything except for the translations first. So we're going to do that. We're going to do that. We're going to do this and this, and we'll leave those 2 translations till last. All right, on our vertical, we have vertical reflection and a vertical expansion times 2, so this is going to become negative 48. And we have our horizontal reflection and our horizontal compression by 3, so this is going to become negative 4. So that's the change after everything in green, right? After all those. Now we can do the translations, which we can put in another color here. So that's what's going to be the result of. If we do our 2 to the left, that's going to be negative 6. If we do our 7 up, this is negative 48, so it's going to go to negative 41. That's the point you get to. Now, if you really wanted to, you could have done it where the horizontal stuff was instead of in this, you could have done it where instead of doing that 2 to the left, you could have done 6 to the right, but as long as you did it before this. Okay, now that ends up being pretty tricky, so it's not necessarily the best way to approach things, but you could, as long as you do maybe we can kind of show that here, even though it's maybe not the safest thing to do. If you did all those same changes, now the vertical stuff I'm just going to leave because we would get negative 41 anyways. Horizontal stuff, we're going to track that 12 and see what happens to it, but we're going to do it in the order of, we're going to do up at the top there, we're going to do a horizontal translation of 6 to the right, and then we're going to do the other 2 things, the reflection and the compression. So horizontal translation of 6 to the right, and then we're going to do horizontal compression by 1/3, and we're going to do a horizontal reflection. So let's watch that. If we do the translation first this time, it's that 6 to the right, you get to 18, and then we do the other 2 things. Compression, it's going to make that a 6. Reflection is going to make it a negative 6. You do get to the same place, as long as you realize the order that has to happen. When there's not that second set of brackets in there, you could do the horizontal shift first, because if you think about it, what's happening here, you go 6 to the right, but then after that, you compress it by 1/3, so really it's like you only went 2 to the right. And then you reflect it, so it's like you went 2 to the left, right? And that's what we had over here. It was actually 2 to the left. If you do the translation first, the other things change it into something else. So when you look at the 2 equations, of course they're going to look different. That one has a -6, this is a +2. Now, this one's a piece of cake. And it's such a piece of cake. No, I better do it here. 1224, those are all vertical. We already did everything in the last one, so this one's not going to change anything now as long as you do that translation last in this form. Even though it's the vertical here, so we're going to do the other 2 things first. Vertical reflection and vertical compression by 1/4, vertical translation 5 up. So if we do all those changes, as long as we do the first 2 first, this is going to become 6 negative, and then we have 5 up is going to give us -1. That's that point that you get to there. Now we'll do something slightly different here. That function in orange is the original function, and we're going to do these changes here. If you look at that equation, you have a vertical reflection, you have a horizontal expansion times 2, you have a horizontal translation, of 3 to the left, and you have a vertical translation of 1 up. It's got that second set of brackets in there, so as long as your translations last, you're good. So if you do the reflection, this point right here is going to go to there. This point right here is going to go to there. This point right here is going to go to there. And this point right here is going to go to there. Now, there's different ways you can do this. You can track the points one at a time. Or you can track the points one at a time, do all the changes. Or you can kind of track the shape all the points one step at a time, as in you can do the vertical reflection on all the points, kind of draw it in. Then do the horizontal expansion, see where all the points go. Or you can do each point one at a time, right? And just think of the coordinates and move that. So what I mean by that is, if I just drew this whole shape here, if I connect the dots here, that's after one step. Okay, I got to do my horizontal expansion, so it's going to end up being there, 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 and there. Oops. So I'm going to get rid of this now so I don't get mixed up. So I've gone to there. Oops, if I drew that properly. It'd be nice if I had a ruler here. Okay, it's gone to there. And then we can go, now we can do our translation and our two translations. If we go 3 to the left, 1, 2, 3, and we go 1 up, that's where it should be. All right, so if you can move the entire function one at a time. Or what you can do is you can track one point at a time. You can take this point right here, let's say, and just make all the changes on that one. Reflect it, goes to there. Horizontal expansion goes to there. 3 over, 1 up, so you know that point's there. And then do the same with the other points. This one, vertical reflection, up to here. Horizontal expansion to there. Translation 3, 1 up, so you get to there, right? You do one point at a time. This one, vertical reflection, horizontal expansion, and then 3 over, 1 up. Okay, and same with the last thing, right? One there, all the way out to here, 3 over, 1 up. Okay, so one point at a time, all the transformations on that, or all the transformations, or each transformation one at a time on the entire graph. Two good ways to do it. And the last thing is going the other way here, which is a bit trickier because it's hard to see what's going on sometimes. But if we know that our the simplest thing to do is to look for what expansions, compressions have happened, and then look for the translations last, kind of the order that you did them in. If you look at the overall shape of the thing here, so the orange is the original and the green is the new one. We have to make kind of a list of what's happened here. It's definitely been vertically reflected because it's opening down and now it's opening up. Now, it may or may not have been horizontally reflected, but let's not bother because it's symmetric. If we look at the height of this thing, that's 3, and we look at the height of this thing, that looks like 9 to me. It has been vertically expanded by 3. And then we look at the width. Is there any difference in the width? There's not a difference in the width. That is 6 wide. That is 6 wide. All right. So if you determine that those two things have happened, vertical reflection, vertical expansion, then we can kind of do those transformations on some points and see where we get to. I'm going to track 3 key points here. If we do our vertical reflection, this point is going to become here. This point is going to reflect, whoops, a little too much. It's going to reflect down to there, and this point is going to reflect up to here. So after our vertical reflection, this is what would happen. You'd have, now it's not going to be drawn very well, but you'd have something like that. And then if we did our vertical expansion on each of those, these two top points would be 3 times as high, and that one would be, that bottom one, it's going to be right at the bottom of the grid. That distance is 2, so that distance is going to expand to 6. So it's going to end up being there, right? Something like this. This is not, again, let's try again. That was terrible. Down. This is not much better, but it's okay and workable. Once you've done those two things, then it's easy to see what translations have happened. This has been shifted 4 to the right and 1 up, right? 4 right, 1 up, 4 right and 1 up. Those two themselves don't matter what order, and the two blue don't matter what order. If we're going to write this equation here, then we have to do a couple things here. We need a vertical reflection, and we need a vertical expansion, so we need that outside. We need 4 to the right. We're going to go x minus 4, and we are going to go 1 up like that, and then we've got it. All right. So there's a few different examples of when you have to think about order of transformations. Again, the thing that matters is as long as it's in that standard form and you do the translations last, everything is okay. And that's it.